Hi everyone, this is a video tutorial on the Heck mechanism. In this video, I want to take a look at each step of the mechanism individually. So in the very first step, we're going to take our vanillic or aryl halide and we're going to react it with the palladium catalyst. This is called oxidative addition. We have added two groups on to the palladium. Let's take a look at the next step. Okay, so let's take a look at the second step of the mechanism. So over here we have our substituted palladium group and our alkene. So now what's going to happen is we have an R group that's currently attached to a palladium, but it could, if it took those electrons, attach to a carbon. This is favorable in terms of energy levels because a carbon attached to a carbon is lower in energy than carbon attached to a palladium. It's along the lines of why we see transmetallation. So this R group is going to come down and attack that carbon. This carbon will now have 5 bonds, which isn't going to work. It can't exceed 4 bonds. So this pi bond will break and it's going to attack the palladium. This allows the palladium to maintain its 4 bonds, and it makes sure that this carbon right over on this side now has a complete octet. Let's move on to the third step. Okay, so let's take a look at the third step of this mechanism. So over here, if you take a look at this group, this palladium has a really large group on it, which would cause a lot of steric issues. So in order to alleviate some energy issues that we're having, we're going to have a hydride come and shift over onto the palladium. The palladium would then have 5 bonds, but it only wants 4. So what's going to happen is these electrons are going to shift down to reform the alkene that we originally had at the beginning of this mechanism. So what we'll have then is this 4 substituted group and this alkene formed. So now this is the end of the mechanism as far as forming the alkene goes, but we still have a little bit of cleanup work to do. So let's take a look at that. Okay, so let's take a look at this final cleanup phase of the mechanism. So over here we have this 4 substituted group palladium. But because palladium was a catalyst, we need to reform it. So what happens is reductive elimination. That's where 2 groups come off of a metal. So we reform the PDL2 and HX. Now our next issue is that HX is an acid and we have an alkene in solution. And an acid will add across that double bond. So we're putting in the ethylene triamine to react and neutralize that acid. So we form this compound, which is not going to react and add on our alkene. And that's the full Heck mechanism.